Hey everyone, today we are going to be going over the Unit 1 test study guide that is the last 2 pages of your packet. We are going to cover the new material that we've done, so all the angle measure stuff. But this is still overall Unit 1 test, so there's also going to be stuff about distance and midpoint. We will review that at the end. Okay, so let's start with our angle stuff. Question number 1 says the measure of angle DEF is 117. So if I follow those letters, that's the whole angle. Find the value of x. So if I know that the whole thing is 117 and then I have the two pieces, when I set this up to solve, I'm going to add those two pieces. So 12x plus 1 plus 5x minus 3 and set it equal to the whole thing. So set it equal to 117. Okay, and then now we're going to solve. I'm going to do a line where the equal sign is at. Okay, first thing we're going to do is check to see if I can combine anything. So these two terms that I'm boxing in both have x's. So we're going to combine those together. 12 plus 5 gives me 17x. Then the two that are not boxed in, so I'm going to underline them, are both constants. So we can put those together. 1 minus 3 gives me negative 2. Okay, and then all of that is still equal to 117. Okay, next step is I want x to be by itself, so let's start by trying to move that 2 over. Since we are going to the opposite side of the equal sign, opposite side, we're going to do opposite operation. So we're going to do a plus sign. So it'll cancel on the left. I'm going to bring down my 17x, equal sign, 119. Okay, and then last step is to move that 17, and we're going to do that by dividing. And our final answer is x equals 7. And that's all that they wanted us to do, find the value of x. Okay, question number 2. If PQS is 16 degrees, so I'm going to label as I go. PQS is that small part, so 16. The measure of SQR is 9x plus 17. So here's SQR. So this section is 9x plus 17. And then the measure of PQR is 12x minus 6. So if I'm not mistaken, that's going to be the outside part. So PQR, P to Q to R. So yes, that's the measure of the whole thing, is 12x minus 6. Find the measure of PQR. So not only are we going to have to solve for x, we are going to have to plug something in when we're done. Okay, so when I set this up, I'm going to add those two pieces. So 16 plus 9x plus 17. And that needs to equal the whole thing. And the whole angle is 12x minus 6. Okay, so same as we did before, line where the equal sign is. On the left, can I combine anything? So the 9x, that's the only thing that has an x. So nothing to combine with, we're going to bring it down. But the other two, 16 and 17, are both constants. So that means that we can add them together, and that would give me positive 33. Okay, and then this still equals 12x minus 6. I can't combine those. Now we have to deal with the fact that we have x's on both sides. We only want it to be on one side. I like to move the smaller one, so out of the two, 9x is smaller. We're going to move that one by subtracting. And now I have 33 equals 3x minus 6. Let's move the 6 by doing the opposite operation. So let's add. And now I have 39 equals 3x. And then our last step is to divide by 3. Okay, so 39 divided by 3 gives me 13. I kind of ran out of space, so I'm going to write it right here next to it. 13 equals x. Okay, but that's not the only thing they asked us to find. They want us to find the measure of PQR. So PQR is this statement right here. So we're going to get our x that we just found, 13, and we're going to plug it in. So PQR would be 12 times 13, I'm plugging in our x, and then minus 6. So you could just type that into the calculator all at once. That's what I'm going to do right now. And I get exactly 150. So that angle is 150 degrees. Okay, number 3. If KM bisects JKL, the measure of JKL is 92 and MKL is 5x plus 1, find the value of x. Okay, so that word bisect, that means that it gets cut exactly in half. So cut in half. I'm going to write that on the side. Okay, so here's KM, and it's bisecting JKL. So that means that both of these sides, I'm going to do the little curve, both of these sides are congruent. They're exactly the same. Then they tell me that JKL is 92 degrees. So JKL is 92. So I'm just going to do like this on the outside, equals 92. But if the whole thing equals 92, and I know it got exactly cut in half, I'm going to do some dividing. So what is 92 divided by 2? And that gives me 46. So each side here has to be 46 in order for it to match. But then they also tell me that MKL is 5x plus 1. MKL, that's this side, is 5x plus 1. I'm going to put that in parentheses. Okay, so since we know that these two measurements are the same, that's what I'm going to set equal to each other. So don't get confused by the 92. You have to remember that bisect means to cut in half. So this one, when you set it up, it's just 5x plus 1 equals 92. Okay, let's do a line where the equal sign is at. Check to see if you can combine anything, but on the left we can't combine, and then on the right there's only one thing. So then the next thing would be try to get that x to be by itself. So I'm going to subtract 1 from both sides. And I get that 5x equals 91. Oh, I just did the mistake that I told you guys not to make. So I'm going to erase this side. So that's good. Y'all saw me make a mistake in real time. We're supposed to set it equal to 46, the half. Okay, so then that makes more sense because now if I subtract 1, that gives me 45. Okay, sorry about that, guys. Okay, and then so next step would be, let's divide by 5. And 45 divided by 5 is 9. So on this problem, we're done. They only wanted us to find the value of x. Okay, and then number 4 in this section. If EF bisects AED, so I'm going to just pause right there. Let's just look at that first part. So EF bisects AED. So that means that both sides here are the same. So I'm going to give myself some markings so I can remember that. This side and this side are the same. Okay. AEF is 4x plus 3. So let's find that. AEF is 4x plus 3. So I'm going to write it sideways just so that it can fit. Okay, and then they also tell us that FED is 7x minus 33. FED is that. Okay, so at the end, they want us to find the measure of CEB. So if we find this, that's going to be this side right here. I'm going to put 2 circles. They want us to find that. Okay, but one thing to notice here is that if you look at these diagonal lines, I have this half and this half. Those are vertical angles. So that means that if I figure out what x is, I'm going to have to plug it in and then find this over here. Okay, so first thing, since these are the same, I could just set those equal to each other. 4x plus 3 equals 7x minus 33. Line down the middle. Can I combine anything here? No. Can I combine anything here? No. So let's move to the next step, where let's try to get x's to only be on one side. So I'm going to move the 4x by subtracting. That leaves me with 3 equals 3x minus 33. Now let's add 33 to both sides. And I have 36 equals 3x. And then last step, divide by 3. So 12 equals x. Okay. Now that I know that 12 equals x, I'm going to use one of these equations up here. And I'm going to plug in 12 where that x is at. So 4 times 12 plus 3, and that gives me 51. Okay, but that only counts, and I'm going to do kind of a curve up here, that only counts for this half. I need to know this other half as well, but since we know that they're equal anyway, I'm not going to bother plugging in anything. They're both 51. Okay, so if I were to add both of those together, 51 plus 51, I get 102. So all the way across is 102. Well, that's what this side is. So that's the final answer that they wanted. So this one took multiple steps. You just have to look at your figure closely. Okay, so that's our first section. Okay, second section, topic 6, angle relationships. So we have some vocabulary that we learned, and that's the video from Tuesday if you haven't watched that yet, about angle pairs. So vertical, adjacent, complementary, supplementary, and linear pairs. And then now I have 6 pictures, 6 examples. So we're just going to label which ones show each of these things. So let's start with vertical angles. Okay, vertical angles are always just going to be across from each other. So if I look at figure 1, those are not across from each other. If I look at figure 2, we're looking at the angles that are numbered. So I'm going to zoom in a little bit. See this one and this one? And these are across from each other. So if I have 2 intersecting lines, they're across from each other. So this counts as vertical angles. So figure B. Okay, figure C, these are next to each other, they're not across. Figure D, these are also just next to each other. Figure E, they're nowhere near each other. And then figure F, they're only next to each other, and I want it across. So B is the only one that shows vertical angles. Okay, next one, which diagrams show adjacent? So adjacent angles, it's like real life. When you are adjacent to something, that means you're next to something. So we're looking for angles that are right next to each other. Figure A, I know they look next to each other, but it doesn't count. They have to be touching, so that one doesn't count. We already know these are vertical, so that one wouldn't count either. Look at C. See how angle 1 and angle 2 are touching? They share a side, so this counts as adjacent. So that's C. Okay, what about D? So this line creates two angles that are next to each other, so that also counts as adjacent. E, they're too far away. And then F, 1 and 2 are right here and they're next to each other, so that counts as well. So C, D, and F all show adjacent angles. Which diagrams show complementary angles? So complementary is if they add up to 90 degrees. Okay, so look at figure A. What is the sum of those two angles? Like, does that equal 90? So let's find out. What is 61 plus 29? That's 10, carry your 1, 6, 7, 8, 9. So yeah, these check out. So A is complementary angles. B would have to be if they add up to 90. I don't know if they do. Like, there's no marking. Like, over here, there is a marking, but this would have to continue, so I don't know what this is. So for B, that's going to be a no. For C, they would have put the little square if it was, so that's also a no. For D, they're making a straight line. That's not 90 degrees, so that's a no. For part E, let's see what that sum is. So 135 plus 45, that gives me 180, so that's not 90. And then part F, those two angles are next to each other, and these actually are going to be complementary because if this side is a right angle, so is this part. That's what we would call perpendicular line. So together they make 90. So diagram F also shows complementary. Which diagram shows supplementary? So with supplementary, we want them to equal to 180 degrees. So I know we had a few of those. That's going to be D. Because when you have a line like that, just a linear pair, we know that that makes 180. So diagram D. And then diagram E, we already did the sum there. And I think those are the only two. Okay, and then part 9, which diagrams show a linear pair? So I just said that out loud. That is diagram D, because they're next to each other and they form a straight line. I don't think any of the others do that. These are across, these are separate. This is not a straight line, these are separate. And then this is only 90, and we wanted it to be line. So D is the only one. Okay, so it's important that we're able to identify those special relationships. But once you're able to identify them, you also have to be able to do some math with them. They all have different rules that go with them. So let's look at numbers 10 through 13. So starting with number 10. Look at the angles that are actually labeled here. We have a number for this angle, so I'm going to kind of color in the corner. And then we also have a label for that bottom one. See how they're across from each other? So like in our kind of diagonal lines, they are across from each other. That makes these vertical angles. And what's special about vertical angles is that they're always going to be equal. So I'm going to put in parentheses. These are equal. So this one's a pretty easy one to solve. Just 10x plus 1 equal sign 12x minus 5. So I can already see that I can't combine anything. So I'm going to start by moving my 10x over to the other side. And now I have 1 equals 2x minus 5. Now let's add 5 to both sides. And I have 6 equals 2x. And then last step, let's divide by 2. So 3 equals x. Okay, next one, number 11. You have to look to see what kind of angles are marked here. So I have this angle and then this side. So that looks like it's making a straight line to me. That's a straight line. So that's a linear pair. And what's special about a linear pair is that when you add them up, it needs to equal 180. Okay, so let's do 4x plus 7 plus 2x plus 5, and that needs to equal 180. So in this one, we can combine like terms. So I have 4x and 2x. When I add them together, that makes 6, so 6x. And then I have plus 7 and plus 5. Together, that makes plus 12. Okay, other side is still 180. Now let's subtract 12 from both sides. 6x equals 168. So then our last step is to divide by 6. And I don't know what that is in my head, so let me put that in the calculator. And I get 28. Okay, so they told us to solve for x, so we're done. Number 12. If m is perpendicular to n, so that's what that symbol is, perpendicular, solve for x. Okay, so on this side, I'm going to write that out. If this is perpendicular, that means that it makes a right angle. So right angle. And we know that right angles are 90 degrees. So here is M and here is N. So where they're crossing, that is a right angle. And that's for all 4 of them. So I'm going to do it right here. Okay. Now the other thing you have to notice about this picture is this angle that's labeled is across from this angle that's not labeled. But those that I just finished highlighting, those are vertical angles, and vertical angles are always equal. So if this bottom one was x plus 21, then the top one is also x plus 21. So what we have now, if you look at just this upper quadrant, is I have 2 angles that when I add them together need to equal 90. So these are complementary angles. Okay, so we're going to add them up. X plus 21 plus 3x plus 9, and it needs to equal 90. Let's start by combining our like terms. X plus 3x, when I put them together, makes 4x. Okay, and then I have 21 plus 9, so that's going to be plus 30. Equals 90. Let's subtract 30 from both sides. 4x equals 60. And then last step is to divide by 4. And x equals 15. And that's all they wanted us to do, solve for x. Okay, and then the next one, A and B form a linear pair. So they didn't give us a picture for this one. You're just going to have to kind of picture it in your mind. They form a linear pair. So in fact, I think we should probably draw it out. So here's my line. And then I'm just going to kind of do maybe a ray going this way. So I have that line and I separated it into 2 angles. So this could be angle A and this could be angle B. So they're telling us that if angle A is 18x minus 1 and angle B is 23x plus 17, find the measure of b. So not only do we need to solve for x, we need to plug it in. Okay, so my linear pair, I know that they have a sum of 180. So let's start there. Add them together. Make it equal 180. Okay, line down the equal sign. Let's start by combining like terms. Oops, I forgot to put an x here. Okay, so combining like terms, 18x plus 23x would give me 41. So 41x. And then minus 1 plus 17 is positive 16. Still equals 180. Let's subtract 16 from both sides. And now I have 41x equals 164. And then last step is to divide by 41. And let's see what I get. 164 divided by 41 is 4. So x is 4. Okay, but now we want to find the measure of angle B. Well, they labeled angle B is that expression, so we're going to plug in 4 into that one. Okay. So the measure of angle B, 23. Let's plug in our 4 we just found, and then plus 17. I'm going to put that into the calculator all at once. So let me do that right now. And that leaves me with 109. So that angle is 109 degrees. Okay, so that's all the new stuff that we've done since the last test. All of this angle stuff. It's a lot of solving equations, guys, but it's also a lot of vocabulary. You need to know what complementary angles are. You need to know what vertical angles are. And all of that is in your notes packet, so just make sure everything is filled out. The last two questions on this review are old stuff, so distance and midpoint, but they do show up on the test that you're taking tomorrow. So in particular, we did use word problems on the test. Number 14 says, Amy throws a ball. She is standing at the coordinate 5, -2. So I'm going to label that x1, y1. And the ball lands at the coordinate 14, 10. So that's x2, y2. How far did she throw the ball? So I know that my distance formula is d equals square root of x2 minus x1 squared plus y2 minus y1 squared. So all I have to do is plug in my numbers where they go, and then I could type this the whole thing into the calculator. Okay, so giant square root. I'm going to start with the x's. So that'll be 14 minus 5. 14 minus 5 squared plus, now let's do the y values. So 10 minus -2 squared. And then just make sure that the whole thing is underneath the square root. So give me a minute to type this all in. Okay, and I am getting a whole number for this. I'm just getting 15. So how far does she throw the ball? It would be 15, whatever the measurement is. So that's our answer. And I know that there's, I want to say 2 problems on the test that are over distance. So you will need this twice. Okay, and then for number 15, this one has to do with endpoint. And sorry about the formatting, the points kind of trailed off at the end. So segment XY has one endpoint at x, which is at 2.5 comma 9. So I tell you what, I'm going to write it over here. So comma 9, and then let's scratch that off. And the midpoint is located at m, which is at 6 comma 5. So I'm going to write the comma 5 over here and scratch this off. What is the location of the other endpoint y? So we did this on the warm-up. I think it was in the video warm-up, so we didn't do it in person. But you can use the formula for midpoint if you truly want, but it's a lot easier if you just think about it as a picture. Okay, so here's my coordinate plane. So we have our x-axis and our y-axis. Okay, I'm going to try to graph these points, but obviously they're not going to be perfect. I'm just going to try my best. So for point x, I have 2.5 comma 9. So 2 would be kind of here, would be 9. So I'm going to say that that's point x, 2.5 comma 9. Okay, and then our next point, m, is at 6 comma 5. So if this is 2.5, 6 has to be kind of farther. And if this is 9, 5 has to be lower. So I would say that that's about here. That's m, which is at 6 comma 5. Now m is the midpoint. So they're saying that if this line were to kind of keep going the way that it's going, where would it stop? So what I would do is figure out how far apart these 2 points are and then just continue that pattern. Okay, so looking at those x values only, so I have 2.5 and 6. How much does it take to get from 2.5 over to 6? So I know some of us can do it in our head, but I'm going to subtract here to the bottom. 6 minus 2.5. And when I type that into the calculator, I get 3.5. So if I were to draw a triangle like this, I know that this part is 3.5. Okay, now looking at only the y values, I'm going to do the same thing. How much does it take to get from 9 to 5? So I'm going to do 5 minus 9. And that gives me a negative 4. So this side, they had to subtract 4. So that's the pattern. Go down by 4 and then go to the right 3.5. So if I do that again, down 4 and then over 3.5, where would I end up? So 6 minus 4. Okay, so let's do this to the side. 6 minus 4 gives me 2. So that's my x value. And then for y, if I have 5, sorry, I messed up again. Let's fix that. Let's start over. X's are side to side. That's what I was messing up here. Okay, so 6, but I want a plus 3.5. That's more better. So that gives me 9.5. And then for the y value, now I'm going to do that minus 4. So 9 minus 4 is 5, but then minus another 4 gives me 1. So that would be my official endpoint over here, the one that we're calling y. It would be at 9.5, comma 1. Okay, so there's one like this on the test, but I think it'll be easier when you take the test because we printed out a blank graph for you to use. So you can use your graph to kind of count how many squares it's been. And yes, the one on the test is going to have decimals, so get used to working with decimals. Okay, so that is the whole review. That's what you're going to need for your test tomorrow, in addition to the rest of this packet. So I would make sure that your whole entire packet is filled in. That way you're ready for the test that we're taking tomorrow. Let me know if you guys have any questions.